Welcome to this lesson on multiplying indices using the first index law. And the first example I'd like to show you is 2 cubed times 2 squared, or 2 to the power 3 times 2 to the power 2. And just a short note, I call these indices most of the time, or a number to the power of something. I don't really use the word exponent. So if you're used to indices being called exponents and you say 2 to the exponent 2, or what's the exponent here, and things like that, I won't be calling them that. So please bear with me. I've been teaching maths for a number of years, and here in Australia the textbooks all talk about indices and index numbers rather than exponents, even though they all mean the same thing: indices, exponents, and powers. So I just thought I'd let you know that, so that you may be wondering why I call them indices, but that's the reason why, and I'm used to it, and it's kind of the way I teach my students, so I'm just going to do the same thing here. Anyway, 2 cubed is a short way of writing 2, and the tablet's playing up a little bit today, and it's still playing up. I don't know why it does that. So it's a short way of writing 2 times 2 times 2, or 2 multiplied by itself 3 times, and it's being times by 2 squared, which is really a short way of writing 2 times 2. And here there are 5 2's, or 2 multiplied by itself 5 times, and in index form that equals 2 to the power 5. So how do you get this 5 from the 3 and the 2? And if you said add them together, you are absolutely correct. So using the first index law for multiplying indices, and the rule is, or the law is, keep the base and add the powers, or add the indices. And you can actually only use the law when the bases are the same, and the 2 is the base here, and the 2 here is also the base. So we have the same base to start with, which is what you need to be able to use the first index law. So keep the base just means write it down again. So there's the 2, and then add those powers together like that, and then that's equal to 2 to the power 5. And that's pretty much all there is to that index law. Keep the base and add the powers. And another example, this time a slightly harder one, with 1/2 to the power 2 multiplied by 1/2. Now, what you need to make sure you do when you copy questions down into your textbook, into your exercise book or folder, is make sure any fractions are in a bracket and raised to a power. So 1/2 is really itself raised to the power 1. And the rule is keep the base, which is the 1/2, keep that in a bracket, and then add those powers, so 2 plus 1, and then our answer, or your answer, 1/2 to the power 3 in index form is the answer. And if you are being asked to evaluate that, like this was the question and it said evaluate this, you would do it like this, and this is just one way of doing it. After this step, you would just cube each number in the fraction, so you would have 1 cubed over 2 cubed, like that, and that equals 1 cubed is 1 times 1 times 1, which equals 1, and 2 cubed is 2 by 2 by 2, which equals 8, and so that's our evaluated or worked out answer. And the general rule for, or the first index law, the formula for it, if you like, a to the m multiplied by a to the n equals a to the m plus n. And a, m, and n can be any numbers, including the number 0. You won't often see a sum like this, 0 squared times 0 cubed, but technically we could work it out. Keep the base, add the powers, and we get 0 to the power 5, which is 0 multiplied by itself 5 times, which would equal 0. I've never actually seen a question like that in my life, so I just thought I'd mention it, just in case you're wondering, can we use 0? So m and n can be 0. A, for the most part, will be whole numbers, maybe negative numbers, fractions. They can be square roots. They can be even things like pi or other symbols. And the powers can be any numbers, including 0. Decimals, fractions, positives, negatives, as well as the number 0. And that's your basic rule. You might use different letters in your rule, like your textbook might be using different letters. Doesn't really matter what the letters are. Key thing is that the bases are the same in these three parts of the rule. There was one other thing I didn't mention about the index law. They can be letters as well, or combinations of letters. So you could have something like h to the 4 times h to the 6, and keeping the base we would have h and then 4 plus 6, adding the powers, and then that would equal h to the power 10. So when you use this, in the index law is what I'm trying to say, applies to any letters, combination of letters and numbers. And the key thing is that whatever you're multiplying together must have the same base, which I've mentioned a couple of times, but just to emphasize the point, so the bases must be the same. So if you had something like 2 cubed times 3 squared, we can't use the index law here because the bases are different. So the first index law is for when the bases are the same, and the rule is keep the base and add the powers. Now that's it for this lesson, and I'll see you in the next one.